All right, so I'm going to be going over all the problems in this practice test, mainly covering linear equations and then absolute value equations and then literal equations. So I'm going to start off with very simple equations and then move on to more, complicated ones. So feel free to just hop around to whatever you need help on. And what I would advise is first, pause the video and then try the problems beforehand and then check to see, how you're doing by unpausing it. So, you give yourself some, little, real practice, but it's up to you. Anyways, here I go. So first we want to solve just each of these equations for the variable. So problem 1, negative 32 equals 4y. And for that, you just got to divide each side by 4. Bang. You get that y is negative 8. All right. 2r divided by negative 8 equals 5. So this is another way of looking at this old school division sign back when you were in like preschool or something. So for this, you just multiply both sides by negative 8. Because that's like multiplying by negative 8 over 1. If you want to be all fraction technical, those cancel. Then you have r over 1, or just r, is equal to negative 40. Bang. Problem 3, k over 3 equals 4. Same sort of thing. 4 is just the same as 4 over 1. So if you want to get the k by itself, you're going to multiply both sides by 3 over 1. These cancel on the left, and then you get 12 on the right. Remember, every number can be rewritten as a fraction. Right, 4, you got z over negative 2 equals 7. But just think of that 7 as like a fraction. Think of it as 7 over 1. Then you can cancel out that negative 2 by multiplying both sides by negative 2 over 1. See? Incredible. And you get z is just negative 14 over 1 or just negative 14. All right, 5, we have 9 equals b divided by negative 1, or you can just put this as b over negative 1 like that. Again, think of it as 9 over 1, and just multiply both sides by that negative 1, or just negative 1 over 1, but you get the idea. So negative 9 equals b. And then for 6, negative 100 equals p over 10. Again, think of this negative 100 as negative 100 over 1. And then multiply both sides by 10 over 1. Multiplying across, 10 times negative 100, negative 1,000. These 10s on the right cancel, and you get negative 1,000 equals p. And there you go. Not a problem. All right, let's move up. Step it up a little bit. Okay, still solving equations. Now we have some addition and subtraction of fractions. So let's see what we got here. So number 7, we got k minus 4/7 equals 2/7. So all you want to do is add a 4/7 to both sides. You add 4/7 to both sides. The 4/7 on the left cancel, and you get k equals 2/7 plus 4/7. Since these have the same denominators, you can just add the numerators. And so then k is just 6 over 7. Don't try to worry about don't worry about changing this into a decimal because this is going to be a irrational decimal. It's going to be messy. Most teachers and I would prefer just to leave it like this. Or number 8. Okay, so this is a good one because this is just -2/9 times d equals 18. But again, just think of the 18 as just 18 over 1. And this -2/9 is just a fraction. This is one that usually gets students. So you can actually cancel out this fraction by multiplying by the reciprocal. So just flip this. It would just be like -9/2. Both sides of the equation multiplied by -9/2. These cancel on the left. And you get d equals -9 times 18. What is that? 9, -90. 90 plus, really don't want to look for my calculator. 90 plus 72, so -162 over 2. Let's not forget the 1 times 2. Simplifying, -81. Not a problem. Number 9. Okay, so this part right here, the h plus the pi over 2. The pi over 2 is just a number. Don't let this like confuse you. So if you want to cancel out this number from the left, just subtract it from both sides. So for number 9, you get h equals 3 pi over 2 minus pi over 2. Now, what is that? Well, the pi is, again, just a number. It's a rational number, so it has a special symbol. But think of it as, when you're combining them, think of it as like 3x minus 1x, or 1 pi. 3 pi minus 1 pi. So then you just get 2 pi on the top. 2 pi over 2. Again, when you're subtracting fractions, don't combine the denominators. Only subtract or add the numerators, as long as the denominators are the same. And these 2's cancel, and it reduces to just h equals pi, or 1 pi. And moving on. Number 10. This shouldn't be an issue as long as you don't let that decimal scare you. Because all you got to do is divide both sides by the 5. What do you know? The t is -1.5. Yep. 11. Yeah, get a fresh new sheet of paper here. 4 plus 12 over 2, or 12 divided by 2, which is going to look like this, equals -5e. They do this just to, mess with you. Yeah, that's really it. So just don't let them mess with you. Show them how smart you are, and you understand that this is just this, which is just this, which is then just this, which is then just going to be this, because you know to divide by -5. And bang, -2 equals v. Also, write your v's with this tail like this, because it's cooler. That shows me that you're like, you're not going to be like the common folk. All right, for 12, a plus 8 equals 9 times. This is old school. This is really going back. So they're just trying to make sure you know what your order of operations are. So here you have a plus 8 equals 9 times 3. Multiply that out first. 9 times 3 is 27 minus 10. So a plus 8 equals 17. Add 8 to both sides, and you get a is 25. When you get the higher math, it's known as a cross product in vector calculus. All right, 12 down. Okay. Now we got to step it up to like some equations where you get to use distribution properties. All right. So 13, we got 12 minus 5 times the quantity of 3r plus 2 equals 17. Okay, so the key here is to make sure you distribute this -5 to both the 3r and the 2. And understand it's -5. So this will be 12 minus 15r minus 10, -5 times 2 equals 17. Combine these like terms, 12 minus 10 makes a 2, drop the -5r, or minus 15r, equals 17. Take away 2 from both sides. -15r equals 15. Then divide both sides by -15. And what do you know? It all works out nicely. R is just -1. What a coincidence. I don't know what's going on with this R. I had a bad day. $14. 3 times x minus 2 plus 5 times 2 minus x equals 16. So again, just make sure that you're distributing correctly. So 3 times x, 3 times -2, then you got the 5 times the 2, the 5 times the -x. So you get 3x minus 6 plus 10 minus 5x equals 16. Combine 3x and -5x, 3x minus 5x, minus 2x, minus 6 plus 10 plus 4 equals 16. Subtract the 4 from both sides. Get -2x equals 12. Then divide both terms by -2. And bang, x is -6. This is a fresh sheet. 15 3 minus, or not minus, equals -1 times a v minus a 4 plus 4 times a 2v minus 9. So again, let's make sure we distribute this -1 to both the v and -4, and the 4 to 2v, and -9. So it's going to look like this. 3 will be -1v, or just -v with the tail there. -1 times -4 plus 4. 2 times, or 4 times 2v, 8v. What the, with the tail? 4 times -9 minus 36. Oh, almost forgot. Now we just, combine. -v plus 8v, 7v. This is just like -1v. And 4 minus 36 minus 32. It's just 4 minus 36. Add 32 to both sides. 35 equals 7v. Then just divide both sides by 7. And 5 equals v. All right. Nice. Powering ahead to 16. 6 times q minus 7 minus 3 times 4 minus q equals 0. Make sure you distribute the 6 to the q and the minus 7. Negative 3 to the 4 and the minus q. So 6q, 6 times negative 7 minus 42 minus 12, negative 3 times 4, negative 3 times negative q plus 3q. That's common mistake. Make sure you change the sign here. Then we combine these q's. They want to be together. 6q plus 3q make a 9q. This is kind of confusing. 9. Negative 42 minus 12. Negative 54. What? Minus 54 equals 0. Plus 54 to each side. 9q equals 54. What? Yeah. Oh yeah, and then we just divide by the 9. And we get q equals 6. Nice. I'm trying to see if I can change this into another dimension. Didn't work out. It doesn't look that good. Q equals 6, guys. That's what it's supposed to say. Sorry if that was more confusing. I did not intend that to be, but Q equals 6. I'm gonna take a 70-second water break because my throat is getting dry. Or what did they say? Parched or arched or parched? I'll be back. All right, I'm back. I've also adjusted the fan so that I get some of the cool breeze. So if these papers blow or shake, and don't mind it, there's not like there's a ghost in here. All right, problem 17 on the back side. Dun, 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 dun. All right, we got to solve these equations. Determine whether the equation has one solution, no solution, or infinitely many solutions. No problem. That's what I do. Okay, some more distribution fun. So let's go 5 times 2f plus 3 equals 2 times 5f minus 1. Again, distribution is the name of the game, which is my specialty. So 5 times 2f, 10f. 5 times 3, 15 equals 2 times 5f, 10f. 2 times negative 1 minus 2. Minus 2. Whoa, as you can see, there's something funky is going on. If you were to take away 10f from both sides, you're going to get 15 equals negative 2, which is not correct. It's not a true equation, not in this universe. So what is that? It's not a solution. No solution. No solution. Depending on what your teacher, wants you to write your answer as, beware. Like, don't say, I will usually tell students kind of get in the mindset that this is false, this doesn't make sense. But false is not like the answer if they're saying, it's asking for how many solutions. You say no solutions, 0 solutions, non-existent, something like that. Just understand like what the concept is. And once you can see that, you start seeing like, oh, there's 10s on both sides, but the 15 and -2, just use your intuition. Right, 18. Right, we've got that 1/3 times 12 minus 24v equals -2 times 4v minus 2. Okay, so 1/3 times 12. Again, you could always use the math or just kind of think, what's 1/3 of 12? Oh, Mr. Dela Cruz, that's 4. 1/3 of 12 is 4. All right, 4. 1/3 of -24. Well, it's obviously -h, -8v. That's right. So again, you could still, do the fancy, fraction multiplication, or just think, 24 divided by 3. Okay, now moving into the other side. Make sure you distribute this -2 to the 4v and the -2. -2 times 4v is obviously -8v. And -2 times -2, 4. Positive 4. What is this? 4 minus 8v equals -8v plus 4. Is this a riddle? Well, what if I do this? What if I add 8v to both sides? Well, you can see the 8v's go away. You get a 4 equals 4? What? What if I take away 4's from both sides? 4 minus 4 is 0. 0 equals 0? Yes, that is correct. This is a true equation, meaning that you can see, like, when you get to a point where you have like what's called an identity, same stuff on the both sides that you can't, isolate a variable, and infinitely many solutions. That means any number for v will make the equation true. I can plug in 1, 2, 3, 17.5, any real number at least will work. Don't put okay, this is my thing. Don't just put infinity, because that's first off, that's not a number, and it's kind of saying you can plug infinity in for v and it's going to work. It doesn't really work that way, and it's not really what the answer or what the problem's asking for. It's to how many there are. You just write it out, and don't be lazy. Don't write like IMF or something. Lazy. 19. 3 times k plus 1 plus 11k equals 2 times 4 plus 5k plus 3. Let's make sure we distribute this 3 to the k, 3 to the 1, 2 to the 4, 2 times the 5k, 3 times k, 3k, 3 times 1, 3, plus the 11k is equal to 2 times 4, 8. 2 times 5k is 10k plus 3. Combine like terms, 3k plus 11k, 14k. Drop that 3 plus 3 equals 8 plus 3, make 11. 11 plus 10k. Let's take away 10k from both sides, like so. 14 minus 10k, 14k minus 10k, 4k plus 3 equals 11. Take away 3 from both sides. 4k equals 8. And divide both sides by 4. And you get k equals 2. So this is the value of k that will make the equation true, but this means that there's one solution, or a unique solution. Yeah, pretty cool. All right, one more of these. -4 times -m plus 2 plus 2m equals a negative 1/2 times 10 minus 12m minus 3. All right, distribution action. Negative 4 times the negative m. Negative 4 times the positive 2. Then negative 1/2 times the 10. Then the negative 1/2 times the negative 12m. Negative 4 times the negative m. As you know, two bads make a positive, so negative times the negative is a positive. Positive 4m. Negative 4 times the negative, or positive 2. Negative 8. Drop this 2m equals, again, just think logically. Negative 1/2 times 10. Well, as you see, if I take 1/2 of 10, that's 5. And since we have a negative sign, negative 5. And then 1/2 of 12, or negative 1/2 of negative 12. Let's just make that a positive right now. Whoa, we know that half of 12 is 6. So plus 6m minus 3. Yeah? 4m and a 2m. 6m minus 8. Drop the 6m. Negative 5 minus the 3. Negative 8. Whoa, what do you notice? Well, we can see there's exactly the same expression on both sides. So when you have this is what's known as the identity equation. So we can eliminate the identical terms. You eventually will get 0 equals 0. So there are infinitely many solutions. Cool. All right, and that gets us to problem 20. Take a water break here. All right, now we're going to enter a new world. No, not Mars, but the absolute value world. I know you guys are excited for this. So here we're going to solve these equations with these absolute value symbols. What does that mean? Well, when you have these absolute value symbols, it's basically asking for values that think of your solutions as think of your solutions as values that are the same distance from something else. So what I'm getting at is on a graph, you can always go to the right or to the left. You can go positive, negative. So you have the number line 0, and you have positive 1, positive 2, positive 3, or you can go negative 1, negative 2, negative 3. The absolute values, you're basically looking at the numbers that are the same distance from some other number. So if let's say you want to find numbers that are 3 units away from 0, there's positive 3 and negative 3. That's kind of like the basic idea. That's why you have to do this technique as setting up two equations. Again, not always this straightforward, but that's the general idea. This is like the magnitude or distance in physics, if you get there. Okay, so the absolute value of p minus 3 equals 10. So we set up two equations, p minus 3 equals 10, or p minus 3 equals negative 10. And then just solve for p in each one of these. Add 3, add 3, add 3. This is kind of weird, but just kind of getting at a point. Your solutions are going to be p equals 13 and p equals negative 7. It's negative 10 plus 3, negative 7. So to be technical, what you're getting at in this problem is So your answers are, let's say, -7 and 13. Like, what, if you notice, what's in the middle of these two? Well, it's going to be 3. Yeah, 3. And they're both 10 units away. This is positive 10 units or plus 10 to the right. This would be minus 10 to the left. That's where that 10 comes into play. Again, they're not always going to be this simple to like represent, but that's kind of why we have to do this technique as setting up two equations. Okay, so getting going, keeping the fun times rolling. 22. So the absolute value of 2k equals 6. The absolute value of negative 2k equals 6. So we're going to have negative 2k equals positive 6, or negative 2k equals negative 6. And just solve both of these. Divide both, or all 4 by -2. Let me just move that away for a second. K equals -3, or K equals +3. So you just plot your two numbers at -3 and 3. All right, next, got absolute value of 6f equals -2. All right, so this is here to fool you. Well, what do you mean? Well, see how this is saying absolute value equals -2? Well, as you know, absolute value can't be a negative quantity because we don't think of it, we don't think of it, by it I mean like distance from something, as a negative quantity. So there are no solutions. No solutions. By definition, absolute value has to be 0 or greater. That's just by definition for this to all work. So we don't get to do anything else. Don't worry, we got another one. Absolute value of q over 5 equals 3. Okay. Same thing. Just because you got a fraction inside here, don't like get all freaked out. K over 5 equals +3, or K over 5 equals -3. What's going on with this 5? Equals -3. So what do? Well, as you can see, you got to cancel out this 5 from both sides. So you do 5 over 1, or just 5. Multiply both sides by 5. I probably don't need to write it over like this, but whatever. And you get q equals 15, or q equals -15. Bang. There you go. All right. Water break. All right. I'm going to get some more printer paper to do the math. All right. All right, here we go. Now it's the fun stuff, finally. You guys are waiting for this. Absolute value equations with absolute value expressions on both sides. So what here? What do we do here? Well, what we do is pretty similar to what we've been doing. Let's have one equation exactly the same as before. And the other one, just make one side multiplied by -1. So the right side, I'm going to have the 2w plus 10 be multiplied by the -1. And I'm just going to solve both of these. That's really it. That's really the only difference. So I'm going to go through these a little more faster, because this is really not this is not really what these problems are going to be about. It's really just a setup, but let's just do one at a time. So focusing on this, let's add 4 to both sides here. So we get 9w equals 2w plus 14. Then we're going to take away 2w from both sides. 7w equals 14. And divide both sides by 7. And we get w equals 2. Right. Now here, we just make sure we distribute that negative first. So we get 9w minus 4 equals -2w minus 10. And then solve like normal. Add 2w both sides. Adding 2w, 11w minus 4 equals -10. Then add 4 to both sides. 11w equals -6. And divide both sides by 11. And w equals -6 over 11. Whoa. Yeah, there you go. Let's do another one. All right, number 26. What about you got something like this? Well, again, have one equation, pretty much the exact same thing, except replace the absolute value symbols. Parentheses, we got 2 times n plus 7 equals 4n plus 8. The parentheses are unnecessary here. And the other one, keep one side the same, except with parentheses, like that, equals, and one side make it multiply by -1. Is she here? And then do the math. So make sure we distribute over here. 2n plus 14 equals 4n plus 8. Take away let's take away 2n actually. 14 equals 2n plus 8. Take away 8. Back up. 6 equals 2n. Divide by 2. 3 equals n. Ba-bang. Or this one now. Distribute the 2 over there. You're going to get the same 2n plus 14. But on the right side, distribute the -1. Both the 4n and the 8. -4n minus 8. Now let's add 4n to both sides. 6n plus 14 equals -8. Take away 14 from both sides. It's 6n equals -22. 22. Divide both sides by 6. And we get n is negative 22 over 6. You can reduce that into negative 11 over 3. Nice. These are your answers. Couple more. Whoa. Technical difficulties, but here we go. 27. And now let's go a little faster. Replace absolute value signs with the parentheses. 3 times the quantity of 3t plus 1 equals 2 times the quantity of 6t plus 3. Or, for the second equation, keep one side the same. That's 3 times 3t plus 1 equals the other side, multiply by negative 1. Let's just make that negative 2. Let's make that positive 2, negative 2 times 6t plus 3. The weird plus, but let's make sure we understand. Then we just do the math. 3 times 3t, 3 times a 1, 9t, sure you got the tail there, plus 3 equals, let's distribute that 2 to the 6t and 3, 12t, make sure you got that tail there, times a 2 plus a 3, so plus a 6. Let's take away 9t from both sides to get 3 equals 3t plus 6. Let's now take away 6 from both sides. So negative 3 equals 3t. And divide both sides by 3. You get negative 1 equals t. Got on. Oh, don't forget this guy. This we already did. Let's just power through it again. 9t plus 3 equals. Now this one, you just got to distribute that negative 2 to the 6t and the 3. Negative 12t minus 6. Let's add 12t to both sides. 21t plus 3 equals negative 6. Take away 3 from both sides. 21t, don't forget the tail, equals negative 9. And then divide both sides by 21. And we get t is 9 over 21, reducing it to negative 3 over 7. All right, cool. These are powerful ones. Okay, it's 2 more of these guys. 29. Let's go. Remove the absolute value signs. J minus 5 equals J plus 9. Or J minus 5 equals negative 1 times J plus 9. You probably noticed something funny. Or I don't know if it's funny. Let's say we take away J from both sides. And we get -5 equals 9. We know that's not true, guys. So no, we just stopped there. This doesn't work. But we gotta check this guy. So we don't have a solution there, but there's still hope. Don't worry, there's still hope to find a solution. Don't give up. So -1 times j and 9, -j minus 9. All right, let's add j to both sides, plus j. On j, we're leaving you 2j minus 5 equals -9, plus 5, 2j equals -4. Divide both sides by 2. Is it true? J equals -2? Man, we have a solution. Or do we? Yes, we do. But again, always check, or, check if you're not sure. Just plug it in. -2 minus 5 and -7. We get absolute value of -7 equals -2 plus 9. Absolute value of 7. 7 equals 7. In case you ever, whoa, that was not a, forgot to move the page around. All right, easier. One more. You can do it. Math requires dedication, persistence, guts. 30. 2k plus 4 equals 2k plus 3. Or, let's keep the next one, the right or the left side the same. Let's multiply the right side by -1. Let's first solve this. So look what you got. We take away 2k from both sides here. We would just get a 4 equals a 3. And that ain't right, guys. This is wrong. No solution there. Again, never give up hope. Never give up hope, because we still have this guy here. So let's see what happens. So 2k plus 4 equals, distributing that negative sign to both the 2k and the 3, -2k minus 3. Let's add 2k to both sides. Right? So we get 4k plus 4 equals -3k. Then we just take away this 4, guys. -4. All right, interesting. 4k equals -7. Then divide by 4. You get k equals -7 fourths. Success. We have accomplished our goal. All right. I'm going to take a minute to do. All right. Now for the final section of this practice test. So the problems you've all been waiting for. Literal equations. Hooray! We only got 8 of them, though. Let's make them count. So g equals 4x plus 5xy. Solve the literal equation for x. Right, this is really fun equation, because what you got to do here, you got to factor out this x like this. Put the x outside the parentheses. Then you have this 4 plus 5y, like that. And what's fascinating is then you could divide both sides by the 4 plus 5y, like this. Then your equation for x is just equal to g over 4 plus 5y. You don't even have to do anything else except box it and make it look nice. Yeah, pretty cool. Anyways, so next one. W equals 4x, ax, minus 9x. I'm being quiet here. I want to see if you can figure it out before I do. Yeah, you got it. I heard that. Heard someone heard the felt the vibes. Same sort of thing. Factor out this x. If you factor out the x from here, we get a 4a minus a 9. Think of it like backwards distribution. And then just divide by the 4a minus 9. Those cancel. And you get w over 4a minus 9 equals x. Bang. What's there? 33. Hold up, let me adjust these. Let me adjust this fan. All right, here we go. 33. Z equals 6x plus px plus 2. Okay, first subtract 2 from both sides. So get a z minus a 2 equals 6x plus px. Now here, let's keep the left the same. Here, you gotta factor out the x. Like that. 6 plus p. That's really the only key thing that's gonna be different from the other ones. You want to subtract that 2 first. Then you just divide the 6 plus p. Divide both sides of the equation by 6 plus p. And you get that z minus 2 over 6 plus p equals x. And bang. Voila. Cool. All right, getting close. 34. T equals 10 plus 7x minus qx. Start off by subtracting 10 from both sides. T minus 10 equals 7x minus qx. Keep the left the same. Factor out this x. You get x times 7 minus q. That's right. Divide both sides by the 7 minus q. You get t minus 10 over 7 minus q equals x. All right, 4 more to go. We're closing in on an hour. Let's try to see if I can get under an hour. Just because. But let's make sure we know what we're doing. All right, so 34, we got x minus bx equals k. ax minus bx equals k. Ax minus bx equals k. Again, by factoring out the x on the left. So we get x times a minus b equals k. And you know what? This might be the easiest one of all. Divide both sides by a minus b. And you get x equals k over a minus b. Dun, 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 dun. Yeah. 31, 32, 33, 34, 35. This should be 35. There. Yep, it should be. 36 now. P equals qx plus rx plus s. Subtract s from both sides, like so. Because there's no x term there. So p minus s equals qx plus rx. It's like a tongue twister. P minus s equals, factor out the x times q plus r. Divide both sides by the q plus r. And we get p minus s over q plus r equals x. We almost got the whole alphabet here. Closing in, 37. 11 minus 4x minus 3jx equals w. Take away 11 from both sides. Negative 4x minus 3jx equals w minus 11. Factor out an x from both of those. X times negative 4 minus 3j equals w minus 11. And no matter how weird this may look, just go with it. Divide by negative 4 minus 3j. There we go. X equals, I'm looking at the clock, we have 1 minute and 37 seconds left. Negative 4 minus 3j. Correct? Correct. Oh, there we go. Correct. All right, un más. That means one more. X minus 8 plus 3vx, almost forgot the tails, equals y. 71 seconds left. Plus 8 to both, plus add 8 to both sides. Cancel. X plus 3vx equals y plus 8. Factor out the x. Ooh, this is a good one. I wonder if you can understand this one. X times what equals x? Dun, dun, 1 plus 3v. Then just divide by the 1 plus 3v with the tail. And you get x is y plus 8 over 1 plus 3v. Bang. There you go, with 17 seconds left to spare. All right, so I did it, so can you. Yeah, let me know if you guys have any follow-up comments, questions, or maybe I made a mistake. Hope not, but that's why I got this duck here, because it's gonna make me feel confident. And subscribe, because that's gonna make you a better person. in many ways. Plus, it's also going to make me feel like I'm important and I have value, that sort of thing. Yeah. All right. Bye.